Hi, I'm Dennis Nagel of Cadence Design Systems. Welcome to Sigrity Tech Tips. Today we bring you another installment of how to sign off on your power delivery network design. Our video today will show you how PCB design teams can optimize the power delivery network design earlier in the design cycle. Utilizing Allegro Sigrity Power Integrity technology, design engineers can capture and graphically validate a topology of the PDN, including all decoupling capacitors. This topology, or power tree, can be used to store information that allows PI experts and non-experts alike to take advantage of virtual push-button setup for AC analysis later in the design cycle. No longer will PCB designers or PI experts responsible for PDN sign-off have to spend hours or even days entering the PDN analysis setup information. Now, as the PCB is going through layout, PCB designers can perform PDN analysis on the planes, pores, and routed power nets for each voltage, ensuring that the critical components meet target impedance requirements. Should the impedance be too high, the PCB designer can make corrections to decoupling capacitor placement or power net routing to bring the design into spec. With target impedance values for each power rail validated by the PCB designer, the PI expert can turn his attention to the difficult task of optimizing the PDN design for the highest performance with the lowest cost. With the comprehensive Sigrity PCB power integrity solution, product reliability will be higher, product costs will be lower, and your management team will be smiling when you go to market knowing that you have a leg up on your competition. In today's video, you will see us utilize the Allegro Sigrity PI base and PI sign-off and optimization option. To learn more about these products, visit us at www.cadence.com. Now I will turn it over to my colleague, Sam Chitwood.
Thanks, Dennis. This video will demonstrate how to automate PDN AC analysis with the new Power Tree utility and Optimize PI. First, create a new Power Tree. Browse to the schematics package folder or netlist location and then click Import. Use the filters at the top to specify component naming parameters. To specify the VRM starting component for this example, type U30.16. Set the DC voltage for the tree and review the negative pins of the VRM. Then click Build Tree. The Power Tree graphically displays the connectivity from the VRM to all IC devices with the decaps initially hidden. This jumper component is not needed, so select Cut Off Branches. Left-click to view the properties for a component. For example, ASI model is a component property that automates mapping between electrical models and the physical design. The expected methodology is to use the Analysis Model Manager to assign all component properties for all devices in the tree. This is especially true for the decoupling capacitors, since there may be hundreds on a single net. Note that Power Tree can display the decaps, but it is common to hide them during most setup steps. Next, launch the Analysis Model Manager and load a corporate AMM library that has been prepared in advance. Examples of resistor, inductor, and capacitor models are included in this library. Select IC devices to see the multiple types of supported models. A unique functionality of AMM is the ability to store a target impedance constraint for IC devices. This allows automatic pass-fail checking against these constraints. Switch back to the Power Tree view and then select Assign Models. Click Auto Mapping and then review the validated component models. In this example, all components models are available in the AMM library. After the models have been assigned, save the Power Tree for it to be used later to automate post-layout simulation and optimize PI. Now fast forward in the design cycle to when the layout is nearing completion. The VDDC power plane is shown on layer 6 and the U2 component is placed near the center of the board. To run PDN AC analysis, we can either access Optimize PI from inside Allegro, or we can open Optimize PI directly. First, create a new workspace. Choose PDN impedance checking to access the new PowerTree integration. Next, load the physical layout database. Next, load the same AMM library that was used during the PowerTree setup. Now load the PowerTree that was created earlier. Note that now when we view the properties of the sink, the target impedance is displayed. Then simply click Apply PowerTree. A summary of the VRMs, decaps, IC devices, and discretes is displayed. The main benefit of PowerTree is its ability to completely set up an optimized PI simulation. For the IC device, an impedance observation was created at component U2 between VDDC and ground. The Target Impedance tab shows that the component's target impedance constraint has been automatically applied from the library. Under the decoupling capacitor setup, we see that all decap models have been assigned. Instead of spending hours looking for models now, that work was completed as part of the PowerTree setup. Under the discretes setup, note that the inductor and resistor have also been enabled. In summary, PowerTree has automated all of the component setup and model assignment. Finally, start the simulation. When the simulation is complete, we see the device's impedance in blue versus the target impedance in red. Obviously, the device does not meet the constraint. Optimize PI also creates an HTML report that can be saved and shared with others. The impedance plots are documented at the bottom. In order to improve the device's impedance, we can perform additional types of analysis in Optimize PI. The switch workflow feature can convert the existing setup into other workflows. First, we will switch to the capacitor to IC device loop inductance analysis workflow. Absolutely no additional setup steps are required. All of the simulation settings are reused from the previous simulation. Simply start the simulation. When the simulation is complete, we see there are only a few decaps that have comparatively high mounting inductance. These are the larger decaps that are physically far away from the device. However, for the decaps underneath the device, there are two decaps with higher values than the others. This is due to the power plane cutouts on the inner layer. Next, we will switch to the IC device power pin inductance analysis workflow. Again, absolutely no additional setup steps are required. Simply start the simulation. When the simulation is complete, we see that there is only one power pin that has comparatively high inductance. Once again, this outlier value is due to the power plane cutouts on the inner layer. The two loop inductance simulations have shown that the layout is well designed. So to improve the device impedance, we must proceed to decoupling capacitor optimization. The first step is to load the original PDN impedance checking workspace. Then use switch workflow to select post layout optimization. Set the analysis type to optimization. And then set the optimization objective to best performance versus number of capacitors. Finally, start the simulation. Using an equal number of capacitors, as shown by scheme 57 in green, we see a dramatic improvement in impedance. This scheme also meets the target impedance constraint. Other schemes also meet the constraint and use fewer capacitors. After selecting the desired solution, the scheme can be exported for back annotation to Allegro. Finally, use Optimize PI to create an HTML report to document the scheme results and easily share with others. In summary, this video has shown how to use PowerTree to automate 4 different types of analyses in Optimize PI. These workflows identify layout problems, optimize decoupling capacitor selection, and perform target impedance pass-fail sign-off analysis. The PDN simulation setup is automatically completed by simply applying a PowerTree. PowerTree enables anyone to contribute to PDN analysis. PowerTrees can be built as soon as the schematic is available. With simulation models now verified at the beginning of the design cycle, this enables automated pass-fail PDN impedance checking to be run for every device on all PDNs. PowerTree enables easy access for design engineers, layout designers, and PI engineers alike. All are equally enabled to run PDN impedance sign-off analysis. And now back to Dennis.
Thank you for watching another edition of Sigrity Tech Tips. For information on products used in today's video, click on the links below or contact your local Cadence sales representative or Cadence channel partner.